A brief break for 2 lessons and then more integration. So we're only going to do something now to help us do more integration. Partial fractions, I think, is the lesson's title. Have you got your book, Fahad?
Yeah.
No, KJ's here. He is more than happy to help his teacher, considering how much I help him. Not true? Alright, so, thank you. Let's have a look here. We are on, I believe we're on page 32. Yeah. Where's your book, Kamara? You're doing a lot of daydreaming in class lately. What's up with you? Dude. Put the bag down, Paul. Just take good notes, please. Let me just fix my pad.
How come the one side is blurry, one side is not?
It's your eyes.
No. This side is blurred.
Alright, Fahad.
That picture is not good for your eyes.
Not wearing glasses when you should is also not good for your eyes. It's okay. One side's good. Alright. Right. As I was saying.
And I can have this projector.
Proper partial fractions. Okay. Right? Okay. So a little bit of definitions first. A rational function is a function of the following form. A polynomial, which I'll explain now in a moment, over a polynomial. Does anyone know what a polynomial is?
Yes.
What is it?
Doesn't ring a bell.
Like a quadratic equation with more than, not a quadratic equation, but like after cubic, after cubic.
You're half right. So a polynomial is a linear, quadratic, cubic, or other type of equation of this form. So for example, here's a very simple rational function. It's a linear divided by a cubic. That's a rational function. Okay? What does the proper part mean though? So the proper part means that the power on the top must be lower than the power on the bottom. So the bottom has the higher power. So for example here it's a degree 1 over a degree 3 equation. So linear over cubic, quadratic over cubic, linear over quadratic, these are all proper rational functions. Yeah. Okay, got these words? Yeah? Okay. Now you know how to do this type of problem. If I asked you to add these together, you don't need to write this part down. If I asked you to add these together, you would say, okay, that's over x plus 1, let's make that a 4, x plus 1 times x plus 3, and then here it's 1 times x plus 3 plus 4 times x plus 1. Yeah? You do your cross and You know how to add fractions. If you don't, talk to your elementary school teacher. So if we multiply out the top, we get this. And if we multiply out the bottom, we get this. So on the top, we get 5x plus 7. And on the bottom, we get x squared plus 4x plus 3. Which is a rational function. Is it proper?
Yes.
Yeah. So what we're going to learn today is the tricky part, is starting from here and going back to here. Yeah, it's as disgusting as it sounds. Yeah.
Not that difficult.
Oh man.
You can try first, you know.
Man. Wait till you see the second class. Okay. So that's the idea. How do we go backwards? So let's start off. I'll do some examples to show you the technique. Okay. So this one you do need to write down. Maybe just before you write it down, just to clarify a concept. There is a tiny difference between this symbol and this symbol. So for example, if I said x squared, okay, if I said something like x squared plus 1 equals 0, what's x? Minus 1, that's fine. Now if I said x plus x is the same as 2x, isn't it? That's true, isn't it? Can you tell me what the x is here? No, you can't. But it's not really an equation, it's an identity. It's like saying x times x. What does that equal? X squared. Yeah? So the way to make the difference clear is when we have an identity, we can use 3 signs. And this tells us that we cannot solve for x, but it is true for all x. So what I mean by that is, if x was 5, is this still true? Yeah, 5 plus 5 equals 2 times 5. If x was 6, 6 plus 6 is also 2 times 6. So the difference here is with equals, you can find x, and with identities, it's true for all x. Yes? You get the difference language here? Okay. So let's have a look at our first example. So I have minus 12 over 3x squared plus 8x plus 4. Are we awake? We're not awake because we're not writing this down. So write this down.
You don't watch any sports?
I do.
Like rugby? Hurling?
Gaelic football, maybe.
Have you ever watched a cricket match?
Oh yeah, cricket match. The only sport I would not watch is American football.
Okay.
What's the difference between
The
that and
ball,
rugby?
It's boring.
What's the difference between that and rugby?
The rules are stupid. It's so slow.
Do you watch baseball?
Sorry, and baseball also. Okay, so the first step you should do here is factorize the denominator. So you can use your calculator to help you here. You get 3x plus 2 and x plus 2 on the bottom. Now this should start giving you a hint for what the answer should look like. If you go back to the example I did, notice that these two terms here, we ended up multiplying them and it made a quadratic. So logically, if I was going backwards, those two factors here, they should be the denominators for the two parts of the answers.
Yeah.
But we realize there's a number here that we don't know and we don't know.
Like we divide by
So there's a couple of strategies you can take. So one thing you can do is multiply everything by the two factors. So what you do is you multiply this by 3x plus 12 and x plus 2. You multiply this by 3x plus 12, x plus 2. And I won't write it again, but you do the same thing there. Now, here, what cancels?
Denominator.
Cancels with 3x plus 12. And here, the x plus 2 cancels with the x plus 2. And what cancels here?
Where?
At the beginning.
Everything.
Because these two are the factors of this quadratic, when you multiply them together, what do you get? The same quadratic. So in fact, both of these cancels this. So you end up with a much simpler problem. Minus 12 equals a x plus 2 plus b times 3x plus 2.
2018.
Hmm? Now, this isn't really an equation. It's more of an identity. We cannot solve for x here. We're saying that they should be the same. So let's simplify on the right. We have ax plus 2a plus 3bx plus 2b. A plus 3b x plus 2a plus 2b. Mm-hmm. On the left, we can say this is minus 12. On the left, we can say this is 0x minus 12. And on the right, we have a plus 3bx plus 2a plus 2b. Now, I hope you might be able to see how we can use this identity to find the a and the b.
Put 0x.
Mm-hmm. Are there any x's on the left? Therefore, I have 0 x's. Any ideas?
Make
Yep.
a equals to 0.
No.
Make b equals to 0. Make a plus 3b equals to 0.
So when we look at the left, we have 0x. And when we look at the right, we have a plus 3bx. If these are the same, then a plus 3b must be 0. On the left, I have a minus 12. And on the right, I have a 2a plus 2b. If they're to be the same, then they also must be the same. So we have a plus 3b should equal 0. And 2a plus 2b should equal minus 4. What type of problem is this? A baby problem, that's right. Where you can use any method you want. Which method do you want to use?
Graphical.
Dude. Which method do you want to use? Whatever method you like, I don't care. I'm just going to solve it and give you the answer.
You can use Gaussian.
So here you'll get a equals minus 9 and b equals 3. So if we go back up to here, well, I'll zoom a bit out. We have our answer. that this is equal to minus 9 over 3x plus 12 plus 3 over x plus 2. That's the answer. There is another way to do this, which I'll show you. Can I go on? Next example. Minus 22x plus 62 over 45x squared minus 19x minus 42. Right, so once again we shall factorize.
Just the bottom.
Just the bottom. Well, the bottom's the only one with factors, I think. Well, I suppose 2 on the top. And then we have that guy, and then we have that guy, and the factors are, firstly, 5x minus 6, secondly, 9x plus 7. So we think that this should equal a over 5x minus 6 plus b over 9x plus 7. What's the next step? Multiply by the two factors. After you multiply by the two factors, what do you have left here? What's left here?
Minus 2x plus
62. Yeah? Equals a times 9x plus 7 plus b times 5x minus 6. This is after you do your multiplication again. Everything in this method is the same until this step. This is where it can be done differently. Yeah. I'm not going anywhere. Continue now? No?
Yes, please.
Yeah? Yeah? So, this next method uses the idea that if these are the same, then they should be true. This should be true for all values of x. So, for example, if I put x as 0 on the left, I should get the same answer when I put x as 0 on the right. If I put x as 1 on the left, I should get the same answer as if I put x as 1 on the right. This should also be the same if I put x equal to minus 7 over 9. Now what happens when I do that? Well, on the left, I'll get, let me type it in, I'll get 712 over 9. On the right, what happens to this piece? Yeah, it's gone. So you just have a b times minus 89 over 9. So, when you solve that, you get b equals minus 8. Yeah? So you can do something similar to get the a. You could say, well, it should also be true if x is equal to...
minus 6 over 5.
If x is equal to...
6 over 5.
That's right. So when you put in 6 over 5, you can get the a. So on the left, minus 22 times 6 over 5 plus 62, and we get 178 over 5. On the right, this is gone. what am I doing? Yeah, this is gone, and you have a times 9 times 6 over 5 plus 7, which is 89 over 5. So you will get a equals 2. So again, you have your a and your b. It's equal to 2 over 5x minus 6 minus 8 over 9x plus 7. Yes, Fahad.
A shouldn't be the same value,
As what?
like, no, sorry, x in all.
No, because you're just making two different identities. So if I said x plus x equals 2x, that's true if you make x 5, and it's still true then later if you make x 6.
Yeah. And x supposed to have like same value in the one equation, or no?
But it's not an equation, it's an identity.
Even identity x supposed.
Identity, no. Equation, yes. Identity, no. So equation, the x must be the same.
For example, in this equation, x could be anything,
X could be anything.
but first you use 7.9 for all of them.
I put that in there.
But you even put there too.
I put this in here,
Yeah.
and it gave me this here.
Yeah.
Then I took this one and put it in, and it made this. So it's like if I put x equals 5 in here, and then if I put x equals 6 in here, and I make these two.
Oh, okay.
Yeah? Which method do you prefer? The first method by making a simultaneous equation, or the second method by substituting in a value for x?
I think it's easy.
Which method?
This one.
Which? This one?
This one.
This exact one?
Yeah.
Yes. So, this could mean anything, I don't know. You could be pointing to the last page in your book saying, this one right here in front of me. But I don't like this method, because you have to use values of x which are forbidden. Here, x should not equal 6 over 5, and x should not equal minus 7 over 9. What values did you use? Those exact values. Dang. Kick in the teeth.
So why can't you use it?
No, I'm saying this method works to use these forbidden values only in this exact situation for a reason we won't go into. So it's enough for me to say it works for these types of problems only, and only these.
Like then we have quadratic and the linear one.
Just this whole concept of finding the a and the b is the only time you can use the forbidden values.
How it's forbidden?
Sounds more dramatic when I say it that way. It's the only time you can use the forbidden values of x for these exact problems. And by exact I mean not just linear or quadratic, but the idea of finding the a and the b.
They're forbidden because they make x 0.
Huh?
They're forbidden because they make.
They make the denominator 0. Yeah, they make these 0. Yeah. Okay. Now we need to make these problems a bit more difficult. So you have the basic idea and the two different methods. Okay. But the situation gets a bit more interesting if, for example, these two were the same.
Which two?
The two factors were the same. So let's have a look at an example like that. So in this example, on the top, you get, well, the same thing, and on the bottom you get this.
last thing with the whole question?
This is the original question here.
Okay.
So, you might think, so what? The factors are the same. Big deal. Well,
If you cross the whole thing out in third step.
Big deal.
well, it is a big deal because if you try to separate them as A equals x minus 5 plus B over x minus 5, like they say in South Park, what is it? You're going to have a bad time? Because what's going to happen here is, well, because these are the same, you can add them together. A plus B is a constant A plus a constant B is just another constant, isn't it?
Yeah.
We'll call it C. Now, you tell me, what number do I pick for C to make this the same as this? Yeah, told you, it's a big problem. So there is a way to deal with this, and this problem is because the root is repeated. So just before we deal with it, some basic ground rules. So if you have a rational function, and you're writing it as an equation, no, what do I call it? I don't want to use A and B, top and bottom. Top over bottom, plus another top over bottom, plus another top over bottom. You get the idea. You've realized that the bottom here is always a factor of the cube. Right? Like here, the x minus 5. How did I get that? It's a factor. And in the last example, what were they? They were factors. So if you want to think about some ground rules, the first rule is that the bottom must always be a factor of q. That's the first kind of rule. The second rule is that it could, or in fact it could also be a factors of q. So there could be some multiplication. Now this second rule, you only ever have to use it if, well, sorry, I'll be a bit clearer here. If two factors are the same, so for example, like what we're just doing here, x minus 5, you can still use x minus 5, but you can also use the factor squared. So what that means here is you could use, you could use x minus 5, and you can also use x minus 5 squared. And if it was a cubed, if it was 3 the same, then you would have x minus 5, x minus 5 squared, x minus 5 cubed. So this is how you deal with repeated factors. It just keeps going up in the power.
If you square it 2 times, a cube 3 times.
Yeah. So if it was cubed, you would have x minus 5, x minus 5 squared, x minus 5 cubed.
In just the repeating case.
In the repeating case, yeah. And then the third rule is about the top. So the top should be lower than the bottom. So for example, if I go back, I know I'm jumping around, but if I go back here, the bottom is a linear equation. What's before linear? A constant. If, for example, the bottom was a quadratic, then you put on the top a linear. So actually I could even be more specific in my rule. I could, where'd it go? Oh dude. Oh no, where'd it go? Ah, I found it. I could even be more specific. I could even say the top should be the bottom less one order. So what I mean by that is a linear on the top is a constant.
It
A
has to be
quadratic,
one stage difference.
well, it could technically be more than one, but at the beginning you assume it's one. When you're writing out the expansion, yeah.
What's before linear?
Constant,
Constant.
yeah.
To solve this equation, we have to write sentences.
No, I'm just giving you basic rules here. And then the last rule is also about the top. The number of coefficients on the top must equal the number of coefficients on the bottom. Sorry, I should have been writing top. Number of coefficients on the top should equal the number of coefficients. Oh, for goodness sake. Should equal the number of coefficients on the bottom minus 1. So what I mean by that is, here, how many coefficients are there? 2. A 4 and a 6. So how many should be on the top? Just 1. So if I had something like 4x squared plus 2x plus 1, how many coefficients? 3. So on the top, yes, there should be 2. And because this is a quadratic, what should I have on the top? A linear. Yeah?
Then the other one is b plus bx plus a.
What's the other one? Oh, well, we'll go back to the example and see, because this is where it comes up. Alright, so I used the first rule and the second rule. Now let's look at the top. What type of expression is this? What's this one called? Linear. So on the top should be constant. How many coefficients here? Well, no, 2.
What's the other one?
There, it's a 1. 1x.
There's only one.
Yeah, but it still counts. There's 2. 1x, 1 and minus 5. Okay? So how many should be on the top? 1. So we'll just call it A. Now, this is where it gets interesting. What type of expression is this? Linear, quadratic, or cubic? So on the top should be linear. So that's A plus BX. Yeah? Wait. Pause. But the fourth rule says, how many coefficients do I have on the bottom?
1,
3.
2. The 1 and the minus 5 again. Original coefficients, I should say. So if I have 2 on the bottom, how many coefficients should I have on the top? 1. And how many do I have at the moment? 2. So that means I must delete A or BX. Which one do I delete? Either. It's your choice. So you can delete A or BX. You'll get the same. You'll get a different answer, but a valid answer that will still work. Okay? So, which one would be, oh sorry, I shouldn't say A and B because I already used A. I should call them different letters. CX plus D. Okay. So which one should I delete? Well, it doesn't matter. Which one would you like to delete, the CX or the D? CX, because you feel like having one less X makes your life easier. So this is equal to A over X minus 5 plus, why did I not use B? What's wrong with me? Doesn't matter. D over X minus 5 squared. And here you have minus 6x plus 22, and here you have x squared minus 10x plus 25.
Who made these rules?
I just made them up. I've never seen them anywhere. They're true.
Yeah, that's it.
They're true. They work,
And
you
they
know,
help.
and they help. But they're not really rules, you know. I don't want to say rules.
No,
Steps-
Guidelines.
steps, yeah, steps.
Yeah. Recommendations. Stephen's personal recommendations.
That's why we say you should add a book.
Yeah. Okay. What do we do next? What do we multiply by?
The quadrant.
Yes, the quadratic, the x minus 5 squared. So what am I left with here? Minus 6x plus 22. What do I have here now?
X minus
A times
that's
x minus 5. And what do I have here?
C.
Well, yeah, sorry, d.
O, D.
I'm multiplying everything by x minus 5, x minus 5, yeah. So those two will cancel. It will cancel once, and it will cancel twice here. Right, so what value should you choose for x to make your life easy here?
5.
5. So you get, let's see, minus 30 plus 122 equals d when x is 5. So you get d equals 92. And then it doesn't matter now what you... Wait, is that 122 or 22? Oh, back in time. When x equals 5. So that's 22. So minus 30 plus 22 is minus 8. Right? So, let me see. Now we have minus 6x plus 22 equals a, x minus 5 minus 8. Now what do you choose for x? It really doesn't matter. Choose anything for x. So what's the easiest one to choose for x? 0. So 22 should equal minus 5a minus 8 when x equals 0. So then you get a should equal minus 6.
I choose the value of x from my head?
Yeah,
Any value?
any value, but you should choose a value that simplifies the identity.
Okay.
So here, Carrara, I chose 5 to make this piece disappear.
Okay.
And here I chose 0 just because 0 is easy.
Okay.
But don't forget, the other way to do it, you could have expanded equals ax minus 5a plus d is ax plus minus 5a plus d. So what can you say minus 6 must equal? A. And what can you say 22 must equal? Minus 5a plus d. And when you solve this, you get a equals minus 6 and d equals 8, minus 8.
I think this way is easier.
Which way? The first way?
Second way.
As you wish. Whichever you prefer.
And now the final step?
Well, that's the answer once you have the two values. So now you can say, what do we say a was?
I was minus 6,
Minus 6. And the d?
minus 8.
Did you write the... Fahad.
Yes, sir.
Did you write this answer down in red? No, you didn't, because you were WhatsApping on your phone.
No. No
Huh?
one's happening.
No WhatsApping? Sorry. No WhatsApp friends, right?
Oh, I do.
KJ doesn't count.
Can you scroll down?
To here? is difficult enough. It's difficult because it's messy.
Since the two materials are really different from since the one.
Oh yes.
It's like
Yes.
really
Yes.
the way the other.
Now, let me convince you that it's the same thing. So what was my first answer? Minus 6 over
X minus 5.
x minus 5 minus 8 over
X minus 5 squared.
x minus 5 squared. So if I add these together, I get this. What's 2 times 11? 22. And 2 times minus 3? Minus 6x, which is what I originally had in the question. So I mean, it's the same thing. They do add together to make this.
They give you this answer.
If I add these together, I get this, which is the question. It's the same thing as this.
If you add this,
If I add these two together, I get this.
well,
No, I'm not asking you to add them together in your head. I'm showing you that if I add these together, I get this, which is correct, because my two answers added together should make the question. I spent all this time writing this in this form. If I add these together, it should go back to this. The computer program agrees. That's what I'm saying. Now recall at this step here,
but
what? What?
go back.
Yeah?
Yeah.
Oh, Fahad. Now, now, where was I? Now here, we deleted the CX. But imagine we deleted the D. Well, I won't do it. It's the same thing. But I will tell you what the answer is. So if you deleted the D, your A will be different. Instead of getting minus 6, you'll get minus 22 over 5 over x minus 5.
You just got like
And instead of getting D here, you're going to get CX, and the C works out to be minus 8 over 5. Now you might say, well, that answer is quite different to this answer.
Yeah.
Like this has no X here, and this has an X here.
Okay.
Can you write this? No, you don't need to write down, I'll type it in. So let's see what the computer says when we add these two together. Do we get the same thing? So the first one was minus 22 over 5 over x minus 5. And the second one was minus 8 over 5 over x minus 5 squared. Now that, I've got my x. Now that looks like a very different answer to this one here. So if we ask the computer to add these together and to simplify, let's see what fraction we get. The same. Amazingly, these two things, although they look so different, they're exactly the same. They add together to make the exact same thing. Which I still think is quite amazing, because this one here doesn't have an x in the numerator, and this one has an x in the numerator. The denominators are the same. The numerators are totally different. And yet it still adds together to make this. And if you don't believe the computer program, you can add these together yourself, and after you simplify, you will get the same thing. I believe it. Good choice. Alright, let's step it up to cubic now.
Oh, it's quite right.
easy, huh?
Hey, this isn't even its final form. Wait till you see the next lesson. Right, so let's have a look at our first cubic one. So we have 48 over 512x cubed plus 1088 x squared plus 632x plus 63 equals 48 over 1, 2, 3. Go ahead. Now, you need to factorize the cubic. In fact, in the exam, they'll give you the factors. So, I'll just use my calculator to get the factors here. Because in the exam, they won't expect you to find the factors as well as find the A, B, C, and D, because that would make the question crazy long.
They give 3 factorial.
Yeah, yeah. So,
Could you make the question 30 marks?
I suppose you're right, KJ. They could. No, you're right. They could give it because the exam now is a little bit different. I just don't think they would. They could. Hopefully they won't. So, anyways, if you get the factors here.
When it's 30 marks, then it's fine.
Yeah, no, if it's worth it, like.
Yeah.
8x plus 1 is the first factor. 8x plus 7 is the next factor. 8x plus 9 is the third factor. So these are the 3 factors.
Fine.
So, to save time, life is short, I'm not going to write this piece out again. I'm just going to write 48 over the cubic. What other cubic could I be talking about except for the one here?
Maybe the last.
Yeah. So, how many fractions do you think would be needed here? Well, it's 3. What's the first denominator? 8x plus 1. 8x plus 7 is the next. And lastly, 8x plus 9. This is a linear with 2 coefficients. What should I have in the numerator?
1.
A constant with 1 coefficient.
ABC.
Next. What's next?
We have to
Multiply
multiply.
everything by the 3 factors. So what happens here? What happens here?
What do you think?
Yeah, the 3 factors cancel the cubics. The first factor cancels the first. The second cancels the second. And the third cancels the third. So you are left with 48 equals A times 8x plus 7, 8x plus 9, plus B times 8x plus 1, 8x plus 9, plus C times 8x plus 1, times 8x plus 7. But it's the same idea. So, to find A, you want to make the other 2 pieces 0. True?
Yeah.
What value of x could you choose to make the second and third term 0?
No.
Come on, children. Looking at this is distracting you. I can see that. Let me help you. So what do you choose for x to make the second and third term 0 to leave you with only the A term?
1 over 8.
Almost, KJ.
Minus 1 over
There we go. So minus 1 over 8. Will this give you A? Yeah.
You have to make the whole thing 0.
Yeah. So what could you choose to make the A and C term 0 to give you the B?
Minus 9 over 7.
Uh,
So A or B, right?
I want the B now.
You want the B,
Yeah.
minus 7 or 8.
Yeah, and what should I choose for x to get the C?
Minus
9 or
8
Yes.
over 9. 9 over 8.
8. 9
Yes.
or 8.
Yeah.
We have 7 and 8, why 9?
Hmm? Here?
Okay, okay, okay.
It's okay? Yeah. So let's see what happens. In the first one, I'll get 48 equals A times a number. In the second one, I'll get 48 equals B times a number. And in the last one, I'll get 48 equals C times a number. Let's see what that number is.
Which number? Okay.
Right, so when I put in minus 1 over 8, I'll get 48 equals 48A. When I put in minus 7 over 8,
Don't say 48.
I'll get 0B. And then when I put in minus 9 over 8,
Minus 48.
interesting, 0 again, just by weird accident. So, therefore, what does the A equal?
1.
Wait, they can't all be 0, that's too weird. Oh, I mistyped. Hee hee. Let me go back to the B.
It can't be 0.
No, they can't. They can't.
Any of
I mistyped. One of them could be 0.
If you multiply.
No, sorry.
No.
No, none of them could be 0. I retract my previous statement. Okay, so for
It's
finding the
online.
B, it's online actually, isn't it, Jeff?
You can just edit and say. Steven said that.
No. When I upload it now, you'll hear the video, and then all of a sudden it'll just go. And then it will jump right back to this part. Yeah. And then you have a test card on the screen or something, signal lost. Oh, but tell me, do you watch that show Colony?
I've not started it.
It's really good. I think it's on like episode 6 or something. Really good. I think you'd like it. You know the show I'm talking about? Colony, you know it.
Yeah, just started.
Just started. Good.
New TV show?
Yeah.
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 I watch it.
Definitely. It's really good.
Watch it online or?
I'm sure it's on Netflix, isn't it?
Yeah.
You have your 30-day free promo still, don't you?
No, it's
After the-
expired a long time ago.
And after that,
But
the
you can watch
Netflix
popcorn,
video.
right?
Yeah.
Yeah, that. Well, I don't know if it's on that. I'm sure it is.
What's the TV shows?
Popcorn is free. For free?
Yeah.
Oh yeah, but I don't know if all the shows are there.
It downloads it to your laptop.
What does?
Popcorn is
Oh, the downloader. It's
Yeah.
not outside.
You can
But you
you
can
can
download any
download it,
episode
like,
from
you can-
Fluent's file.
Yeah.
But for this TV
Anyway.
show, can I watch it?
Watch it. It's good.
Steven, for this TV show, can I watch it online?
Yes.
Oh yeah.
Okay.
Yeah. What's
That's okay.
I can't remember the American station.
So only one numbers to read?
American station.
Oh.
Not BBC.
ABC series.
I think it's ABC.
Yeah, that's that one. Yeah.
Okay, now let's find the B, which is not 0, by the way. So if I put in minus 7 over 8 in here, this will go, and I'll be left with 8 times minus 7 over 8 plus 1. 8 times minus 7 over 8 plus 9. So I'll get minus 12 here for this one. And then when I put in minus 9 over 8 into the last one, I get 16. So here I can see that A equals 1, B equals -4, and C equals 3. So I have my answers. A is 1, B is -4, and C is 3. Okay.
Another example. One more example.
Oh, for sure. Two more examples maybe. But I might not fully do them. I might just do enough to get to like this step. Because I think once you get to this step, everything just follows.
Yeah.
Okay, so let's have a look now at a quadratic but with one of the factors repeated.
Yeah.
Factors repeating. Oh, this is not.
Sorry, cubic with a factor repeated. So let's have a look at h then I. So h here, 16x squared plus 65x plus 18 all over 28x cubed plus 36x squared plus 15x plus 2. Right, so we'll cheat and get the factors from our calculator.
Okay. Oh, so long.
You have this function in your calculator to solve the whole thing.
You do on this one.
No, not the factor. The whole thing.
Oh, the whole thing? No.
Maybe in this.
Yeah, maybe. So the three factors are 7x plus 2, 2x plus 1. Now the calculator only gives me two factors.
Why?
That means one of the factors was repeated.
So which one?
Don't know.
That is a good question. Now we can figure it out easily though. Look please. Fahad, put the phone on the desk beside you. We're having similar issues over here.
No.
We were.
Yes.
Yes. So which factor is the one repeated? Well, consider both possibilities. If I were to put 7x plus 2 here, this would be wrong. Because what is 2 times 1 times 2? 4. 4. Not 2. If I put here 2x plus 1, what's 1 times 1 times 2? 2. So it must be this one that's repeated.
Can I add a note?
Yeah. Oh, for sure, yeah.
We can check on the way. The one to
You could do what? Long division.
No, long division. To find the factor, you can tell us.
Dude, listen to me. I just said, and you were probably typing on your phone when I said this. The calculator only gives me two factors.
Yeah. The 3. It's because cubic.
Yeah, there should be how many?
3.
3. So like I said, one of the factors must have been repeated. The calculator won't tell me which one was repeated. No, don't believe me. Verify for yourself. No.
I'm not believing you.
No. Please, go ahead. Be my guest. Right, so it was the 2x plus 1 which was repeated. Yeah. So what do we do next? What's our next step?
Multiply by 2.
Multiply by the three factors.
Wait a minute. We have to separate it.
Oh yeah, sorry, I'm skipping a step. Separated. So we have 16x squared plus 65x plus 18. Life is short. What goes here? The cubic.
Or you can write the C, huh?
No, goodness, no. No, don't do that. Right, what's the first fraction here? 7x plus 2. And what's on the top?
A.
The next one?
2x plus 1 squared.
2x plus 1. B. And the last one, KJ, redeem yourself.
So x plus 1
Oh, KJ. Squared.
squared.
What's on the top? This is quadratic, so this must be linear. So it must be cx plus d. However, how many coefficients are here?
4.
2
Sir.
in the bottom. So how many coefficients on the top? 1. So one of these we can make 0. Which one will make our life a little easier?
Yeah.
Yeah, so we might as well just forget about that one.
Can you read that again, please?
The last thing.
Okay. So there are 2 coefficients here.
Okay.
So there should only be 1 coefficient here.
One coefficient, okay.
This is quadratic, this must be linear. But because there's 2, there should only be 1 here. So one of these I need to make 0. I must cancel one of them. In fact, I can cancel either.
Okay.
I will get a different answer that will turn out to still be the same.
But which one you will choose?
Any. We choose this to make 1 less x.
Okay.
Yeah. Easy.
It's easier. Now what's the next step?
Multiply by that.
Multiply by the 3 factors, so you're left with 16x squared plus 65x plus 18 equals a times, who can tell me this?
2x plus 1 cubed. Sorry.
Go ahead.
Squared.
Squared.
Plus b times
7x plus 2. 2x1.
very good, plus d times
7x plus 2. That's
now I won't do the next step fully, but I will say what values of x to choose to get the a, b and d. Right, so firstly, if I make x equal to minus a half, that will give me what? A, b or d?
D.
It'll give me d.
yeah.
If I say let x equal minus 2 over 7, that will give me,
A.
it'll give you a. Because this and this will be gone.
Yeah.
If I say let x equal 0, that will give me a, b and d. However, I know the a and I know the d. So I can put in those answers and I'll be left with b. If I put these answers in to the last one.
If you put x, dx.
If I put x is 0 and the value of a and the value of d, which I found previously, I will have only b left to find.
Can you do the
One
last
more. Huh? Can I do what?
The last one.
No, because then I'll have to do the first 2 to get the a and the d.
Exactly. Because it's even let x equal minus half, give what?
D.
Give d.
Because these 2 will go. What's the problem with the last part I had? Now everybody stop writing. For 20 seconds, your full attention, please.
Oh.
Full attention, 20 seconds. If I make x equals minus a half, this will go and this will go and I'll get a d.
Yeah.
Okay.
If I make x equals minus 2 over 7, this
D
will
will
go,
go.
this will go, and I'll get a.
Yeah.
Do I have the a and the d?
Yeah.
Yes. Now, if I make x 0, will any of these go? No. They'll all stay. But,
Half of them will.
do I know the value of d here? This part.
Yeah.
Yeah, I'll be left with 12 times d because the x is 0. Do I know the d? Yes. What happens when I put x0 here? What am I left with? 1a. Do I know the a? Yeah, so I know this piece, I know this piece. This will be 0 and 0, so I'm just left with whatever that is. Yeah, 2 times 1. And this will be, what will this be when I put 0 in? 18. So can I get the b there? Yes, of course I can. B is the only thing I don't know. Yeah? Okay. So, we'll look at one more example. But, yeah, I'll just write the last one down here. I'm going to finish up with I. Right, if you have your Casio calculator, I would like you to give me the factors of that cubic.
That's odd.
Is it? Is it really? What's odd?
It's, x1 is minus 0.742.
No, you typed something in wrong. That's the first problem. Okay, so here, this cubic has only one root. So there is still another factor, but if this is linear, what is the other factor here? Quadratic. The calculator doesn't give me this. The calculator only gives me the root. So there's only one root here, and the other term is a quadratic. Now, how can I find that quadratic?
Long division.
Yes, long division, what and what?
3x and the
3x plus 1 divided into the cubic. What will that give me, KJ? That will give me, it'll give me the quadratic, won't it?
yes.
So we can get the quad this way. Fahad, you're staring at your calculator, come on. You're going to ask me the question I just explained here. So you divide the linear into the cubic and you get the quadratic. So that means your question
So the
will
calculation,
equal,
it doesn't show the quadratic.
no it doesn't, it just gives you the roots. So your question will have a root here, a linear and a quadratic. So, how many fractions will this be? No, only 2.
Yes.
The first one will be 3x plus 1, and what will be up here? Constant. This here will be the quadratic. How many coefficients are in the quadratic?
3.
We won't factorize the
It's impossible. Impossible. This quadratic will have no factors. Because if it did have factors, then we would have gotten them already.
Yeah.
This quadratic will have how many coefficients? 3. 3.
In total,
3 in total. So how many on the top? 2.
3.
And it needs to be a linear, so it must be bx plus c. And you know the usual step. So what's next then? We multiply by the factors. So you would end up with just the top, whatever that was, equals a times quadratic, whatever that was, plus bx plus c times
3x plus 1.
3x plus 1. And it continues like this. The difficult part really is getting to this step. Then once you have this step, all you need to do is carefully choose the x. The correct choice of x will give you the a, b and c easily. Huh?
Will help a lot by choosing the correct text.
You choose,
It'll help a whole lot.
you choose 0, you get A.
If you choose 0, you will not get the, you will get the A. Very good. So if you choose 0, you'll get the A. Because this will just be 1, this will, oh no, there'll be a C here. No, nice try. If you choose -1/3, then what will you get? Then you'll get the A, because this will be gone. Yeah. Now look, semester 2, things are getting more difficult. I've got bad news for you. These are section A questions.
Yeah, section A question.
Yeah.
How's that bad news?
Oh, okay. I got good news for you. These are section A questions. Okay. Now look, this lesson required both classes to do, and the next one we might get it done in one class because you have the concept already. But then the classes after that may also require doubles because they're going to be long as well. But then the good news is once we hit page 40, we move on to something which is a little bit easier. Only a little.
So what's the homework then?
Now, really, no, dude, I don't check the homework. So if you don't care about your future and don't do the homework, that's your business. So if you're really serious, you would need to try the right column here, because each question here is a different form of a problem. Some of them have repeated roots, some of them don't, some of them are linear, quadratic, cubic. I made all these questions, yes. Everything in this book, every single thing in this book I typed.
Did you copy it?
No copying.
Not from any textbook.
Not from any textbook. Everything is 100% me. 100%. No question here you will find in any other textbook or website. And if you do, please tell me because they plagiarized me. Okay? Every single letter in this book is original.
Sit down and make questions.
Look, I have problems. I have issues to work out, okay? All right.
How long it took you to make this book?
Best part of a year.
That's like
All this fun?
9 months. Like the time it takes to make a game.
Yeah, but which would you rather have?